Welcome to Tech Explained. Today we are covering the Model Context Protocol, or MCP.
Right. And it's a really interesting one. Imagine you want your AI assistant, the one you chat with, to maybe find a specific document buried somewhere in your company's database.
Okay.
Or perhaps get it to schedule a meeting for you. Now, historically, these large language models, they've mostly been stuck with just their training data, right?
Yeah.
Or whatever you specifically told them in the prompt.
Yeah, they couldn't really reach out and interact with external tools or, say, live data sources.
Yeah, they were kind of isolated.
So our goal today is to really get into MCP. It's an open standard, came out from Anthropic late 2024, and it's designed to, well, bridge that exact gap, to let LLMs work with real-world information. We'll break down what it is, how it functions, the problems it's trying to solve, look at some practical uses, and also touch on the challenges. Consider this your way to get up to speed on how AI is getting poised to be much more deeply woven into your daily workflows. So, starting right at the basics. What exactly is the Model Context Protocol?
Fundamentally, MCP is a standard, an interface. It lets AI models connect up to external data sources, tools, services, but in a really consistent way.
Okay, a consistent way.
Yeah. You could think of it as a sort of universal adapter.
Yeah.
Like how USB-C works for charging lots of different devices.
Ah, right. One port for many things.
Precisely. But for AI applications, it lets different AI systems access this wide range of external stuff, data, tools, in a pretty straightforward plug-and-play manner.
A universal adapter for AI. I like that. So it's not locked down to one company or one specific model then.
That's the key point. It's an open protocol. The specifications are public. Anyone can implement it. It's not proprietary. Anthropic, who make the Claude models, they kicked it off.
Right.
But the idea, the intention, is for really broad adoption. Across the whole AI community, we're talking models like OpenAI's, ChatGPT, various open source LLMs, anyone, really.
So the big goal here is to standardize how these models get context, meaning the information and the tools that live outside their original training data.
Exactly that. MCP standardizes how that external context is fed to the LLM and how they exchange information back and forth. The aim is really to break them out of that isolated bubble they've been in, make them much more useful in the real world.
Okay, that makes sense. So we understand the what. How does MCP actually work in practice? What's going on under the hood?
Well, it uses a client-server architecture, and there's a common message format they use to talk.
Client-server, okay.
Yeah. And the technical bit is that the communication between the AI and whatever it's connecting to via MCP uses something called JSON-RPC 2.0.
JSON-RPC 2.0.
It's just a lightweight way, using JSON, to make requests and get results back from a remote system. Think of it as a structured language they both agree on. Importantly, this communication is usually stateful.
Stateful? What does that mean in this context?
It means the connection stays open. It's not just a one-off request and response. They maintain a continuous connection, which allows for back and forth conversation, essentially.
I see. And that's important because
It's crucial for context. If the AI asks a tool to find a document, and then in the next step asks it to summarize that document, the stateful connection means the tool remembers which document was just found. Sure. The AI doesn't have to specify it all over again.
Got it. That statefulness seems like a really big advantage for keeping track of things during a task. So what are the main pieces involved in this architecture?
You've got three key components. First, the host. That's the application where the LLM is actually running maybe a chat interface or your code editor. The host starts the connection.
Okay, the host.
Then inside the host, there's the MCP client. It's a component that specifically manages that MCP connection. It's kind of the middleman on the AI side.
Right.
And finally, you have the MCP server. This is usually a small server or maybe a service that sits in front of the external data source or tool like your Google Drive or a database. It's the bit that actually provides access to that external resource.
And these MCP servers, they offer specific capabilities that the AI can then use.
Exactly. The servers expose what they can do. These capabilities are typically categorized as tools, which are actions the AI can ask the server to perform, like querying a database or sending an email.
Okay, tools for actions.
Then there are resources. These are usually read-only things, like the content of a specific file. And finally, prompts, which are more like predefined templates or workflows that can guide the AI for certain tasks.
Interesting. Could we walk through a quick example, say how an interaction might flow if an AI wants to use one of these tools?
Sure. Let's say an AI needs to access something on Google Drive. The whole thing starts with initialization. The host application, with its MCP client, connects to the Google Drive MCP server. They do a quick handshake, basically swapping protocol versions, checking capabilities, making sure they can talk properly.
Okay, handshake done. They can communicate.
Next up is discovery. The client asks the server, okay, what can you actually do? The server responds by advertising its available tools, resources, prompts. It's like showing the AI its menu. So the Google Drive server might say, I offer a search file tool and a read file tool.
Got it. So the AI learns what options it has from that specific server. What happens then?
After discovery, there's often context provision. The host might ask the server for some immediately relevant context, maybe a list of the user's recently opened files on Google Drive. This gives the AI some initial awareness, some grounding.
Ah, so it gets a bit of starting info.
Right. Then comes the invocation step. Let's say during your conversation with the AI, you ask it to summarize the latest sales figures. The LLM figures out it needs data from the finance database. Its reasoning triggers the MCP client to call the right tool, maybe a query database tool, on the finance database's MCP server.
So the AI itself doesn't touch the database directly. It tells the client, which tells the server, run this query.
Precisely. That leads to execution. The MCP server received that request, parameters and all, and it actually performs the action on the external system. It runs the query against the database. It gets the results, packages them up, usually as a JSON response.
And then sends it back.
Yep, that's the final step, completion. The result, that JSON response with the sales figures, is sent back through the client to the LLM. The LLM can then process that data and give you the summary you asked for. And because of that stateful connection we mentioned, you could then ask follow-up questions about those figures.
That whole flow sounds quite structured, actually. You mentioned earlier it was inspired by something in software development.
That's right. The Language Server Protocol, LSP, really standardized how code editors talk to language-specific tools for things like auto-completion or error checking. It meant you didn't need a unique plugin for every single language in every single editor. MCP is aiming for something similar. For AI, standardize how models connect to external tools and data, making integration much easier.
Okay, that parallel makes sense. So, digging into the why a bit more. What's the fundamental reason for setting up this standard? What core problems is MCP really trying to solve?
The absolute primary reason is to break AI models out of their isolation, to connect them to all the useful data and services that exist outside their training set. Before something like MCP, if you wanted your AI to talk to, say, your company CRM and your email and a specific database,
You need separate, custom-built connections for each one.
exactly, a custom integration for every single link. That led to this really fragmented landscape. Lots of different connectors, hard to manage, hard to scale. It was a mess.
A maze of connectors, essentially.
Yeah, pretty much. MCP offers one universal protocol to replace that maze. Instead of dozens of bespoke pipes, you have one standard conduit for accessing tools and data. This idea of moving from custom work for everything to a standard protocol. Well, it could really speed up how quickly AI gets built into new things, maybe even create whole new types of AI tools we haven't thought of yet.
That fragmentation issue certainly sounds like a major bottleneck. What other big improvements does MCP bring to the table?
Well, it dramatically reduces development effort. If someone builds an MCP server for a tool, say Salesforce, then potentially any AI model that understands MCP can use that server to interact with Salesforce. No need for every AI developer to build their own Salesforce connector from scratch.
Ah, the reusability factor. Build once, use many times.
Right. And it also helps maintain context across different systems much more smoothly. Imagine you're working on a project. You could ask your AI about an email thread, then switch to asking about related tasks in your project management tool, then maybe look up a relevant file in cloud storage. MCP could potentially allow the AI to keep track of the overall task context across all those different tools.
And presumably, accessing external up-to-date data improves the actual answers the AI gives.
Absolutely. That's a huge benefit. Instead of relying only on potentially outdated training data, the AI can fetch current user-specific information. If you ask, what were our sales figures last quarter? Or show me the latest code commits for Project X, an MCP-enabled AI could go and get that real-time data. The answers become far more relevant and accurate.
This sounds like it also enables AI to do more complex things, maybe acting more autonomously.
Precisely. MCP is a really important enabler for what people are calling agentic behavior. AI acting more like an agent that can perform multi-step tasks. Because it can maintain state and call different tools in sequence, an AI could potentially handle a whole workflow.
Like what, for example?
Well, think about onboarding a new employee. An AI agent, using different MCP tools, might be able to create their user accounts, send out standard welcome emails with necessary documents attached, schedule orientation meetings in their calendar, maybe even check that each step was completed successfully. MCP is really designed to help AI take those kinds of autonomous actions within safety limits, of course.
Okay, so just to recap the main problems MCP is tackling.
Right. First, fragmentation replaces all those one-off connections with one standard. Second, data isolation lets AI access real-time specific data outside its training. Third, workflow continuity helps AI keep track of context across different tools and steps. And finally, developer convenience. Tool builders create connectors once, and AI developers get access to a whole ecosystem.
That's a very clear picture of the benefits. So where are we actually seeing MCP being used right now? What are some real-world examples?
Adoption is definitely growing, especially in a few key areas. One big one is enterprise data access. Companies like Block and Apollo, for instance, they've started using MCP. They're building internal AI assistants that can tap into their own databases, their knowledge bases, analytics tools.
So like an internal chatbot that actually knows stuff.
Exactly. Imagine a customer support bot using MCP. It could instantly pull up your specific account details, your recent orders, past support tickets, all directly from the company's CRM system while you're chatting with it. Much more helpful.
Definitely. What other areas are seeing activity?
Developer tools and coding assistance is another major one. Anthropic's own Claude Desktop uses it. And tools like Zed, Replit, Kademium, SourceGraph, they're leveraging MCP too.
How does it help developers?
It allows the AI assistant to actually see the code you're working on, look at related files, check pull requests, understand database schemas. It gets a much richer context of the whole project. And that means it can give way more accurate code suggestions, find bugs better, just be a more useful coding partner.
So AI becomes a much smarter pair programmer, basically.
Essentially, yes.
Yeah.
Then there's personal productivity and multi-tool agents. We're seeing open source MCP connectors pop up for tools many of us use daily: Google Drive, Slack, Notion, Git, even web browsers.
So I could connect my AI to my own tools.
That's the idea. You could potentially tell your AI, find that presentation I made last month on Google Drive and send the link to Sarah on Slack. And it could coordinate that task across both tools using MCP.
That kind of seamless workflow could be a huge time saver. Any more unusual or forward-looking applications?
Yeah, a couple of interesting ones. IoT and automation. You could connect AI to smart home devices via MCP. Imagine asking your AI to look up a research paper, check online if it's missing any key citations, and then turn on your desk lamp because it's getting dark, using 3 different MCP servers potentially.
Okay, giving AI control over the physical world.
Within limits.
Yeah.
And also early days for cross-agent collaboration. The idea here is maybe you have multiple specialized AI agents, one for legal, one for finance, and they could use MCP to share information about the same client, keeping everything consistent. Really, MCP is showing up wherever AI needs to be, less passive, more aware of context, and more capable of taking action. It feels a bit like how standard app stores and APIs help smartphone apps take off.
That's a powerful analogy. MCP seems like it's building the infrastructure for a more capable AI future. But like any tech, especially one connecting systems, there must be challenges, limitations, downsides.
Oh, absolutely. It's definitely not without its hurdles. Security concerns and trust are probably top of the list. When you give an AI the keys to access external tools and potentially sensitive data, you're opening up new avenues for problems.
Like what specifically?
Well, things like robust authentication and authorization, making sure the AI is allowed to access that tool and only do specific things, that's still evolving in the standard. There's the risk of connecting to a malicious MCP server or a legitimate server being compromised. And prompt injection attacks could become more dangerous if a compromised tool can be used to make the AI do harmful things. Sandboxing and fine-grained permissions are really critical here, and they're being actively worked on.
Security is always paramount when connecting systems. What about data privacy?
That's another big one. Data privacy and the risk of leakage. Making data access easier also makes it easier to accidentally expose sensitive info. MCP itself doesn't really enforce strict data boundaries or encryption within the protocol layer. So users really need to be careful about which tools they enable and what data those tools can see. Enterprises especially will need extra layers of governance and protection.
And what about the user experience? Does MCP introduce any complexities there?
Potentially, yes. Under user oversight and UX limitations. We want AI to be more autonomous, but users need to stay in control, especially for actions with real consequences. MCP doesn't currently have a built-in way to signal the risk level of a tool, or if using it might cost money, for example.
So the AI might just do something significant without warning.
It's a possibility that needs careful design to avoid. There's also the risk of just overwhelming users with permission requests if not handled well. And the fact that MCP is mostly text-based right now might limit how well it works for tasks needing very interactive real-time feedback loops.
What about the practical side of actually implementing this, especially for businesses with older systems?
Right. Integration complexity can be a real challenge, particularly with legacy systems. If you have an old internal tool that wasn't designed to run as a server process or speak JSON, building an MCP server for it might be quite difficult.
And migrating existing custom connections.
That requires refactoring effort, definitely. Plus, adding this extra MCP layer can sometimes make debugging harder when things go wrong. There's just one more piece in the chain.
Does this extra layer impact performance or ability to scale?
It can, yes. Performance and scalability are things to watch. Making external calls through MCP, serializing data back and forth, that adds some overhead compared to a direct, tightly integrated system. Latency can creep in, especially if servers are far away or many calls are needed.
So the servers need to be robust.
Exactly. The MCP servers themselves need to be built to scale if they're going to handle lots of requests. And the current spec is still a bit light on things like automatic retries or failover if a server goes down.
It sounds like the standard and the ecosystem around it are still quite young.
That's fair to say. Early adoption and an evolving standard bring their own issues. Industry support is growing, but it's not universal yet. The number of readily available MCP servers for common tools is still building out. Documentation, best practices, community knowledge, they're all still developing.
And potential for changes in the protocol itself.
Yes, as it evolves, there could be breaking changes that require updates. And finally, there might be limitations in specific domains. Think highly regulated industries like finance or healthcare. The current MCP feature set might not tick every single box for compliance, yet things like detailed audit trails or specific certifications might need more work or external augmentation.
So definitely a powerful concept, but with real challenges to navigate, especially in these early stages. Given all that, what are the main trade-offs involved when deciding whether to go down the MCP route?
It involves balancing several factors. One key trade-off is generality versus specificity. MCP gives you this great universal connection, lots of flexibility. But a custom-built integration for one specific tool might be more optimized, more performant, because it's tailored just for that.
So flexibility versus potentially squeezing out the last bit of performance.
Kind of. Then there's performance versus extensibility. As we said, MCP has a bit of overhead, which might slightly impact speed compared to direct calls, but the payoff is huge extensibility. You can add or swap out tools much more easily without messing with your core AI application.
What about the level of control?
That's the autonomy versus control trade-off. MCP enables more autonomous AI behavior, which is powerful. But it means developers give up some direct, step-by-step control over exactly what the AI does and when. That requires careful thought, especially for critical operations where you might want more explicit oversight.
And the development process itself.
There's complexity versus maintainability. Setting up the initial MCP infrastructure might seem a bit complex, but in the long run, managing connections to many tools via one standard protocol could be much simpler to maintain than juggling dozens of unique, custom integrations.
Makes sense. Are there broader strategic trade-offs for an organization?
Yes. Consider scalability of development versus scalability of infrastructure. MCP makes it easier to scale up the development of AI capabilities by leveraging many tools. But your infrastructure, the MCP servers, the underlying systems they connect to, needs to be able to scale to handle the actual operational load.
Right, you need both.
And finally, standardization versus innovation. Committing to a standard like MCP fosters interoperability and lets you benefit from community improvements. But it might sometimes slow down adopting very specific cutting-edge features if they aren't part of the standard yet, compared to building something proprietary.
It really sounds like a strategic architectural decision, weighing those immediate challenges against the long-term vision of flexibility and interoperability.
It is. And often the long-term benefits, that flexibility, the easier integration, enabling more powerful AI, are seen as outweighing the current hurdles, especially as the MCP ecosystem matures and best practices emerge.
Well, this has been a really fascinating look at the Model Context Protocol. It definitely feels like a key piece of technology shaping where AI is headed next.
I think so too. MCP offers a very compelling vision, doesn't it?
Yeah.
A future where AI is more connected, capable, because we've standardized how it interacts with the world around it.
And while those challenges we discussed, security, privacy, maturity, are real and need careful attention,
They do.
the potential payoff in terms of seamless workflows, access to current information, it seems massive.
Absolutely. So as you, our listener, think about AI becoming more integrated into your work, into your life, understanding protocols like MCP is really valuable. It helps you see how these systems are evolving beyond just their training data, how they're actually starting to connect with the tools and information you use every day.
We definitely encourage you to think about the implications here. What new possibilities could a truly connected AI open up for you? And maybe just as importantly, what kinds of safeguards do you think are most crucial as these systems gain more autonomy? It's a space that's changing incredibly fast, and MCP is right at the heart of it.